Hello everyone, this is Anirudh here. I am a third year undergraduate of the Department of Computer Science and Engineering enrolled in IIT Kanpur, and I am a BTech student. I secured All India rank 237 in JEE Advanced 2021, and I'm a resident of Chennai. Right? And today we are going to be dealing with the chapter trigonometric functions. Right? This is chapter 3 of class 11 maths, right? Because I think there's another chapter in 12 with the same name. Right? And this basically deals with, a more advanced version of what trigonometry you learn in class 10, right? In class 10, you learn about what sine, cos, tan are. And here you are going to deal with what their functional forms are, right? How you use them in functions, how you use them in higher level maths, right? So again, this is going to be an introduction that trigonometry is derived from, angle measuring or measuring the size of a triangle, trigon and metron, Greek words. Right? And you have what are angles, you have what are lines, you have what's a degree measure. Right? And people remember that you have two types of degree measures, that is in degrees, that is a sextant system, where you have 360 degrees making up one complete revolution. And you have the radian system, which deals with multiples of pi, right? And remember that the conversion between radians is that pi radians is equal to 180 degrees, right? Because basically what a radian is the arc length of a degree, right? This one radian is a unit arc length of a circle, right? Of a unit radius. So you have the fact that pi radians is 180 degrees because 2 pi radians is going to be the complete circumference, that is going to be 360 degrees, right? So this is going to be your this is going to be the conversion, right? And you have the formula that L is equal to R theta, where theta is the angle measured in radians, right? And so you have the relation between radians and real numbers, that radian measures and real numbers can be considered as one and the same, right? Whereas degrees and real numbers cannot be considered to be the same, right? Because you have 180 degrees to 360 degrees making up one complete revolution, which means that the real number line is going to be stronger. Relation between degrees and radians I've already told you, and you have this handy table where you are going to deal with the the most frequently occurring degrees and the most frequently occurring radian conversions, right? A notational conversion where you usually deal with the fact that radian measure is pi by 180 into degrees and degrees 180 by pi into radians, right? And thus we jump into exercise 3.1, which is just an exercise to make it comfortable for conversions between radians and degrees, right? So exercise 3.1. Question number 1. Find the radian measures corresponding to the following degree measures, that is 25, minus 47, 30, 22, 40, and 520, right? First of all, we are going to deal with 25 degrees. Fairly straightforward. You know that radians is basically pi by 180 into degrees, right? Which is the formula above here. Very good. Yeah. So with this formula, I can basically substitute instead of d, I can substitute 25, and I'm going to get the radian value. That is going to be pi by 180 into 25, right? Which is this goes 5 times. Here, this goes 36 times, right? So this is basically 5 pi by 36 radians, right? Which if you want to represent in decimals, you can, but 5 pi by 36 radians is perfectly valid, right? Question number 2. Minus 47 degrees, 30 minutes, right? Remember that minutes is a sexagesimal system, right? Therefore, you have the fact that 60 minutes makes 1 degree, right? And in the same way, 60 seconds is going to make up 1 minute, right? This is basically the same way that you classify meter, decimeter, centimeter. There's going to be degrees, minutes, and seconds, right? You don't have, there are actually no further units than seconds, but if you want to, you may write them as milliseconds, whatever. But yeah, I digress. Right? So with this in mind, you have the angle measure as minus 47 degrees, 30 minutes, right? Which is basically minus 47 degrees. And this is minus of 47 degrees, and this 30 minutes which is basically half a degree, right? Because 60 minutes makes up 1 degree. That means half of 60, that's 30, is going to make up half a degree, right? So this I can basically represent as minus 47.5 degrees, right? No problem in, there's no problem in actually writing this way, 47.5, 47.3. There's no problem in doing that. But people, it's a convention that you do not, mention decimals in degrees. You mention decimals only in sec. Right? So you convert it. So most texts usually convert it to minutes. There's minus 47.5 degrees, and then with this you apply the radian conversion formula again. That is R is equal to pi divided by 180 into d, which is going to be pi divided by 180 times 47.5. Do not forget the minus, right? Which is basically, since 47.5 is 95 by 2, I can write this as minus 95 pi divided by 360, right? Just I'm writing that 47.5 is 95 by 2, right? And so multiplying to 180 is 360, and 95 comes over here. The minus sign is here. And so I'll basically divide this by 5. This is going to be what, 19, and this is going to give me 72, right? So this is basically minus 19 pi divided by 72, right? And I should not forget the measure, right? Radians. Subpart number 3, fairly straightforward. This is going to be 240 degrees, all right? So you don't have any minutes or any other things confusing. Fairly straightforward. Plug it in the formula. R is equal to pi by 180 times 240, right? 0, 0 cancels out. Both are divisible by 6. So I'll get a 3 over here. I'll get a 4 over here. So this is basically 4 pi by 3 radians, right? Of course, you can also do it this way. Since you have the fact that 60 degrees is pi by 3, right? And you know that, yeah. And you know the 240 is basically 4 times 60 is basically 4 times the radian measure of 60. That's 4 into pi by 3. That's 4 pi by 3. And you can also do it that way. Nobody cares, right? You just have to arrive the correct answer. Because these kinds of questions are going to only be asked in 1 mark questions in CBSE board if they do so. So that's not a it's not a big deal, right? So this is 4 pi by 3 rad. And the last question, that's going to be 520 degrees, right? This, is fairly difficult, right? In one sense, degrees cannot exceed 360 because exceeding 360 is pretty much meaningless, right? But they've given this question in a sense that they want you to think of the radians as numbers on the real line, which extend from 0 to infinity. So what you do here, you don't overcomplicate things by, by subtracting 360 from this and then converting that into radians, but you do so with the given degree value itself, right? Do not get confused with that. You do it with the given values only. Right. So you have the fact that the radian measure is going to be 520 times pi by 180, right? I'm sorry for my shoddy code work. This is pi again. Yeah, this is going to be pi, right? And I'll cut a 0. I'll cut a 0 over here. This is what? I'll cut a 2 here, a 2 here. So you basically get 26 pi divided by 9 radians. Yeah. Right. And that finishes the first question. Second question. Find the degree measures corresponding to the following radian measures. Use pi equals 22 by 7. Right. So since again pi is 22 by 7, that's a lot. Right. And again, you're going to be fairly straightforward your substitution in the formula. First radian measure given is 11 by 16 radians, right? You know that degrees is 180 divided by pi into the radian measure, right? Since I've given that pi is 22 by 7, I'll condense this formula to write degree measures is equal to 180 times 7 divided by 22 into R. right? And I'll cut a 2 over here because I want to simplify things for me. So this is going to be 9 sevens are 63. That's 630 divided by 11 into R. All right. So now we have for the first question, your D1 is going to basically be, wait, where did it go? Yeah, 630 divided by 11 into the radian measure, that is 11 by 16 radians. Right, 11 cancels out. You are left with 630 by 16. Right, which is basically what? This is 315 divided by 8 degrees, right? Which is which I have to mention in the decimal form. This is going to be 8 3s are 24. You're left with 75. That's 8 9s are 72, and you're left with 30, right? And 30 is basically 3 7. Wait. Yeah, it's 375 degrees, right? Which, if you want to convert this into a more natural form for degrees, is going to be 39 degrees into this is 375. This is, wait, so this is 0.375, right? 0.375 is 375 by thousandth of a degree into 60. That's the conversion to a minute, right? This is basically what? This is basically 60 into 3 divided by 8, right? This goes, here you're left with 2, here you have a 15. So you have this 15 is a 45 by 2, that is 22.5, right? So you have 22.5 minutes. So I'll write this as 22 minutes and 30 seconds, right? That is going to be the degree conversion. 39 degrees, 22 minutes, 30 seconds, right? Again, reminding you that you should not leave decimals and degrees. You have to convert it to minutes and seconds, if so, right? Support. You have -4 radians, right? Since I have the formula D is equal to 630 divided by 11 times R, right? I'll directly substitute this in R. This is going to be minus 630 into 4 divided by 11. That is going to be what? This 4 6 are 24 and this is 120. So this is 2400 and 120, that becomes 2520 divided by 11. Not to forget the minus sign, right? And this is degrees. So basically, I'll write this as minus, this goes 2 times, right? And again, you have 20. This is a 9 point. 29.0101 degrees, if I'm not wrong, right? This is 229.0101 degrees, right? And since I have this, this is basically 1 by 11. All right. So if I have to convert this into minutes, I'll multiply this by 60. All right, from which I'll get 60 by 11. That is what? 5.45, right? This is 5 and 5 by 11. 5 by 11 is 0.45. Yeah, it's going to be 5.4545 minutes, right? And again, this part is going to be 5 by 11. If I multiply this by 60, I'll get this is what? 300 by 11. That is going to be 27 point what? Fairly straightforward. 27.2727, right? So you basically have your T2 is equal to The first part is minus 229 degrees. The second part is 5 minutes. And the third part is going to be 27.27 seconds. Right? If you want to, you can also drop this, this last point, because in seconds, it does not matter if you have a point, because the value of 1 second is very, very, very less. Right? You really can't measure 1/10 of a second in angles, that is. In time you can, not in angles. Right? That concludes D2. Right? So even if you don't want to write this 0.27, it's okay. You can just drop it off as minus 229 degrees, 5 minutes, 27 seconds. That's it. I've done this just for the sake of being accurate. Good. Question number 3. This is 5 pi by 3. Very straightforward, right? Because you have a pi over here in the reading measure itself. You can basically write this as, d is equal to 180 divided by pi into r, right? Which is, I'll write this as d3 to differentiate it from whatever we have done above. So d3 is basically equal to 180 divided by pi into 5 by 3 into pi. Pi and pi cancels out. 3, this goes off at 60. And so you are basically left with 300 degrees. Right? That's your answer. Very straightforward. Right? Similarly for the fourth, right, you have 7 pi by 6. So your D4 is going to be 180 divided by pi into r. Right? Again, since you have a pi over here, I'm keeping this in the 180 by pi format. If there wasn't this pi, then I would have gone with 630 by 11. That is basically 180 by pi, where pi is substituted to 22 by 7. Right? And so we have, this is going to be 180 divided by pi into 7 by 6 into pi. Pi and pi cancels out. 6, this goes with 30. And so you have D4 as 210 degrees, right? Because 30 into 7 is 210. Right? And that completes the second question. Right? Third question. More like a word problem to make you think. A wheel makes 360 revolutions in a minute. Through how many radians does it turn in 1 second? Right? Since you have n per minute, npm is going to be 360. Right? Where npm is basically the number of revolutions in a minute. Right? So nps, that is number of revolutions per second, is going to be 360 divided by 60. Right? Because in 60 seconds, it makes 360 revolutions. That means in 1 second, it's going to make 360 divided by 60 revolutions. Right? We are assuming that it's rotating at uniform speed. Right? That's an assumption, a fair assumption to make in maths, not in physics. Right? And so you can basically state that the number of revolutions per second is going to be 360 by 60 uniform, right? Which is basically 6. Right. Therefore, radians per second is going to be 6 into radians per revolution. Per revolution. Right? Because it turns 6 revolutions in a second. Right? And if you multiply 6 into the number of radians per revolution, then you get the number of radians it turns per second. Right? So you have 6 into 2 pi. Right? Because 1 revolution is basically 1 complete circle. Right? And 1 complete circle is 2 pi radians. Because 2 pi radians is 360 degrees and 360 degrees makes a circle. So we have the fact that the radians per second over here, right, what they've asked, RPS, is basically 602 pi, that is going to be 12 pi. Right? If you want, you can, convert this pi into decimals and say that this is going to be 36 point something decimals. But, leave it as 12 pi. This is better looking and better to write. And it's easier for the examiner to see also, instead of converting to decimals and them, checking your maths. Don't do that. Question number 3. So we are going to question number 4. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeter by an arc of length 22 centimeter. Use pi is 22 by 7. Right. So I'll just draw, a not to scale diagram. I'm warning you. Right. But yeah, you are given that the radius is basically 1 meter. Right. You have an arc L of length 22 centimeters. Right, that is basically 0.22 meters because I'm using 1 meter over here. Right, there is a reason I'm using 1 meter. I'll tell you after I solve this, after I finish solving this. Right, and you're asked this angle. Right. Remember that you have the formula L equals R theta. Right. Since R is 1, I'll basically cut it over here. Right, because 1 into anything is that anything. So on the right side, I'll have basically theta. On the left side, I have 0.2. Right? So therefore, your theta is 0.22 radians. Right. Now, since they have asked the degree measure of the angle, you can leave it at radians because that's not what they've asked for. So you have to convert this into degrees. You know that degree is equal to 180 divided by pi into r. And since I have condensed this formula earlier, this is basically this is basically 630 divided by 11 into r. Right, since I have given that you use 22 by 7 for pi, making the substitution earlier is 630 by 11 into r. Since r is 0.22, right, r is theta, right, r is the radian measure, that's theta. So we have d is equal to 630 divided by 11 into 22 divided by 100, right, because 0.22 is 22 by 100. Everybody knows that, right? If you do not, then you are in much worse a place for being 11. Yeah, jokes apart, right? Cutting this off, you get 2 over here. This goes, wait, let's not do that. Right, I won't cut this 2 because having a denominator 100 is pretty easy to, work with. So I basically have, this is 630 times 2, that is going to be 1260 divided by 100. Right, that is going to be 12.6 degrees. Right, then again, remember that I told you never to leave degrees and decimals. So this 0.6 is going to be 6 by 10 into 60. That is going to be 36 minutes, right? So you have your degree measure is 12 degrees, 36 minutes, right? And that is your answer. This is the required degree measure, right? And since I told you why I take 1 meter instead of 100 centimeters, that's because by the definition of a radian, right, it's the radian measure of an angle is the arc length of a unit circle that subtends that angle at the center, right? So if this theta is going to be some whatever degrees, you take this arc length for a unit circle, right? And that arc length is going to be the degree, the radian measure. So if I have a unit circle over here, 1 meter, that means that whatever length I'm going to take over here is going to be my radian measure as seen over here, right? Since L is equal to R theta, if R is 1, then L is theta. That's basically my logic. That's why I took 1 meter instead of 100 centimeters because I didn't, unnecessarily make calculations by dividing by 100, etc., so on and so forth. Whatever. Right. Finally, is all the same. You can do whatever. It's just one simple step away. But yeah. Question number 5. In a circle of diameter 40 centimeter, the length of a chord is 20. Find the length of minor arc of the chord. Right. So again, drawing a circle, take the center. Yeah. So this diameter, since this is center, let me mark it as O. this be the radius, that is going to be 20 centimeters, right? This radius is also 20 centimeters, right? And you have a chord of length 20 centimeters, right? I'm drawing this parallel because it does not really matter. The radii can be drawn anywhere, anyhow, right? So let the chords endpoints be A and B, right? Then joining OA, joining OB, you see that OA is a radius, OB is a radius, and radius are of length 20 centimeters, right? Since all these three lengths are equal, that means that triangle OAB, first of all, without reading the question fully, I'll write this down, right? Triangle OAB is equilateral. Yeah. Saying this is easy, writing this is hard. Wow. All right, whatever. So you're asked to find the length of minor arc, the chord, right? Remember that the minor arc is going to be this arc. So you're basically asked to find the length of AB, right? Length of AB you find by using the formula L is equal to R theta, where this length is going to be L, right? This length is going to be L. So you have the formula L is equal to R theta. Here we find out what L is, right? You know what R is, and you can figure out what theta is, because theta is going to be this angle, right? Since triangle OAB is equilateral, that means that angle AOB is going to be equal to both the other angles. That means that each angle is going to be 180 divided by 3, that is going to be 60 degrees. Right? If I convert this into radians, that is going to be pi by 3. From the table mentioned above, right? And directly taking the values for that. Instead of using formula. Right? That's another step, which I don't want to do. So since angle AOB is pi by 3, this is theta. Right? Therefore, length of the chord AB, L, is going to be 20 centimeters into pi by 3. This is centimeters, right? This is basically 20 by 3 pi centimeters, right? Which is, which you can leave as such, no issues. But since this is the length of a chord, you usually, convert this into decimals and then write it down, which means that this is going to be 20 into 3.14 divided by 3, that is going to be 20.933 centimeters. Right? If you want to get 2 into it. But this form is also okay, pretty okay. Right? There's not much bigger deal. Over here, I've used the fact that pi is 3.14 instead of pi is 22 by 7. So I have got this. If you use pi is 22 by 7, you'll be off by a little bit from this amount. If you use a more precise version of pi, you're going to be off from this amount by a further margin, of course. Right? Having taken care of that, that's question number 5, right? Yeah, this is question number 5. Here you have question number 6. If in two circles arcs with the same length, subtend angle 60 and 75 at the center, find the ratio of their radii. Right. So you have, first of all, 1 and 2 of different lengths, right? You're given that you have let this be R1 and let this be R2. Right. This length be L, right? This is theta 1. For the same length L, right? Since this is going to be the center, this is going to be R2, right? Which means that this length, this angle is going to be theta 2. Right. You know that L is basically equal to theta 1 R1 for this circle. And for this circle, L is going to be equal to theta 2 R2. Right? Since you're given that both these lengths are equal over here after the same length, right? Therefore, you have the fact that theta 1 R1 is going to be equal to theta 2 R2, or R1 divided by R2 is going to be equal to theta 2 divided by this is theta 1. Theta 1. Right? This is going to be the major logic that I'm going to use in this case. Right? In two circles of the same length, subtend angles 60 and 75 at the center. Therefore, they've given us that this is basically 60 degrees, and this angle is 75 degrees. Right? I should have interchange these angles because this is very close to 60, but even then this whatever. This is not a scale. All right, people, this is not a scale. Forgive my shoddy drawings. All right. So given that theta1 is 60, theta2 is 75, you have the fact that R1 by R2 is now going to be 75 divided by 60, which is basically 5 by 4. Right? Therefore, the ratio of radii is 5:4. Right? That's right. Remember that for the same length, if you have a smaller angle, the radius is going to be bigger. And if you have a larger angle, the radius is going to be smaller. With that, you can, rudimentarily check your answer. If that basic fact is also invalidated, then that means you have arrived at the wrong answer. That's one way to check what if you have done right. The other way is basically by, reversing the steps, trying to see if you can arrive at the question. But yeah. Question number 7. Find the angle and radian through which a pendulum swings if its length is 75 centimeters and the tip describes an arc of length, blah, blah, blah. Right? So basically, for the 7th question, you are given an incomplete circle, right? You have the center point. You have the radius, that is 75 centimeters, right? And you have the arc length. So if I, mention this as the arc, right? You are given this length then. You're given this length then, right? With that, if I, complete the segment of the circle, sector of the circle, then this angle is what you're asked to measure. Correct. This is going to be the general drawing for all 3 cases, right? It's not like they have, given the amplitude of the pendulum. You assume that the amplitude is basically greater than the greatest value in each subdivision, right? But so of course, find the angles and radians through which a pendulum swings. If it's 75 and the tip describes an arc of length 10 centimeters. That's the first subpart. Right. So you have 10 centimeter being equal to L, because the tip describes an arc of length 10 centimeters, means that the tip is going to move through 10 centimeters from minus A to plus A. For all physics notes, that's the left endpoint and the right endpoint, right? So this length is basically what this means, right? The arc of length is basically this L. So L is 10 centimeter first of all, right? Since you know that L is R theta, that means that theta is going to be L divided by R. That is going to be 10 centimeter divided by 75 centimeters. That is going to be 2 divided by 15 radians, right? This is going to be theta 1. So I'll write that theta 1 is 2 by 15. Right. For the second subpart, your L2 is going to be equal to 15 centimeter. That means theta 2 is going to be L2 divided by R2, right? From over here, right? Which means I'll directly substitute. This is 15 divided by 75. That is basically 1 by 5. That is 0.2 radians. Right? Remember that radians are basically real numbers. So you can mention 0.2 radians, 0.13 radians, or pi radians. Pi radians is also a value. 3.141592, whatever radians is actually a value. Right? Radians can be irrational. It's not like radians have to be rational. Yeah, I digress again. So you have the fact that number 2 is basically 0.2 radians or 1 by 5 radians, whatever. Right? And finally, the third subpart, that is going to be just a line over here. This is L3 is going to be 21 centimeters, right? that means theta 3 is going to be equal to L3 divided by R3, which is 21 divided by 75, right? Which is basically 7 by 25 radians, which I can, represent decimals as 0.28 radians. Both forms are correct. You can write any one of these forms. I prefer the decimals because that's just me. Right? You can also write this as 7 by 25. There's no big deal. You'll be awarded for pass. With that, we complete exercise 2.5. The next exercise deals with the actual functional trigonometry, right? Where you extend the definition of trigonometric ratios, the trigonometric functions, that is sine x, sine of whatever, sine theta, cos theta, tan theta, whatever you have learned, right? You extend that to real numbers, where instead of just dealing with sine of some values, say theta, where theta has to lie between 360 and 0, right? Which is what you've learned in our 10th, which is the quadrant system. Right, you are going to now deal with this. You are going to transform to sine of x, where x belongs to the real number line. Right? Wait, just draw this properly. Yeah. I usually like to, differentiate my real numbers, this R, and the whatever result capital R I draw, because this is a special set, and you have to give it its own importance. Right? And you should not confuse this with any other. That's it. Yeah, so you're going to basically transform this function, this kind of a ratio, into a function which exists for all real numbers x. Right. So you have a big, derivation, consider a unit circle, blah, blah, blah. And then you're going to deal with your basic trigonometric ratios for the, most frequently occurring angles, 0, pi by 2, pi, 3 by 2, 2 pi, etc., etc. Right? And you see that there's a sine of 2n pi plus x is sine x, cos 2n pi plus x is cos x. Right? This is basically a cos of a sine of 360 degrees into n plus whatever degrees is going to be sine of whatever degrees. Right? The 2 pi is 360, and 360 times whatever plus, say 45 degrees. Right? 45. And then 405 and what 765, whatever, they are going to have the same sine value. Similarly, the same cos value, because fundamentally speaking, 365 degrees, 405 degrees is basically 360 plus 45. That's 45 degrees. Right? That's the fact that they're using over here. Right. So this is basically a solution of a trigonometric equation. Sin x is equal to 0 implies that x is n pi, because sine of 2n pi plus x is sin x. Right? And cos x 0 implies that x is 2n plus 1 times pi by 2, which means that for cos x to be 0, x has to be an odd multiple of pi by 2. Right? And the other angles, of course, cosecant, secant, tan, and cot. Right? And you have the handy table over here. But instead of 0, 30, 45, 60, you have 0, pi by 6, pi by 4, pi by 3, pi by 2, pi, 3 by 2, and 2 pi. Right? But it's the same table. It's the exact same table. There's no difference. Right? And coming to the next part, that's sine of the trigonometric function, right? How you determine the sines is again same way, but instead of having 90 to 180, you have pi by 2 less than x less than equal to pi, something like this. And then you have instead of 180, this transforms to this. Instead of 180 to 270, right? I'll just write degrees over here. Right? Instead of 180 degrees to 270 degrees. This gets transformed to 2 pi less than x less than equal to, this is 3 pi by 2. Right? It's not 2 pi, just 5. Right? And similarly for 270, 360, you have 3 pi by 2 less than x less than 2, less than equal to 2 pi. So like this. Right? You don't actually need to do the equality. Right? Because they become 0 at that point, or something that's not real. Something like that. And then you deal with the domain and range. Since you all know functions, you know that every function has a domain, every function has a range. And for sin x, cos x, you see that their values are basically bounded between -1 and 1. Right? If you see the graph over here, I have a graphical ready just for that. Right, you can see that the value of the function sin x on the real line, right? X is the real line. It's basically bounded between the values -1 and 1. It does not go beyond, it does not go under, but it's always bounded between -1 and 1. Therefore, you have the domain of sin x, the domain of y equals sin x being real, domain of y equals cos x being real. But the range of sin x and cos x is basically the interval, closed interval, -1 to 1. And you know how to deal with 1 by sin x, you know how to deal with 1 by cos x, you know how to deal with tan x and cot x. If you don't, then draw the graph, you'll figure it out from there. That's all I can say, right? And you have this handy tip, the behavior of trigonometric functions in the first, second, third, and fourth quadrant, right? Where you deal with the increasing, decreasing nature, right? Which you'll also deal with in the derivatives chapter, because this is basically to do with the derivative of the function sin x, right? F of x is sin x. But I won't, deal with that over here. We'll learn that in derivatives. We have a lot of time for that. So yeah. Right. And remember that tan x increases from 0 to infinity, right? The range of tan x, this is a very, very crucial remark, I have to say. The range of tan x is basically the real numbers, right? A tan x can get the value of all real numbers, but the domain of tan x, is all real numbers, right? Right. It's basically real numbers minus the set of 5 by 2, 3 pi by 2, blah blah blah, and minus pi by 2, minus 3 pi by 2, blah blah blah. Right? Because at each of these points, tan x becomes infinity or minus infinity. Right? As you can see over here. Right? If I say x is equal to pi by 2, right? You can see that this line basically never meets tan x, right? If I zoom in a bit, you can see that there is always a distance maintained between the red line and the blue line, which means that you can't, you can't say that the red line never becomes equal to the blue line. So you have domain of tan x being r minus the odd multiples of pi by 2, while the range of tan x is the real number line r. Right. Having said that, you deal with repetitions, that is the period of a function. Right, you get to see that the period of sin x and cos x is 2 pi, right? Because this wave repeats again after a 2 pi interval, right? The period of tan x and cot x is basically pi, right? Because you see that this wave repeats itself for a degree of pi, right? So this, if I take, something greater than, just greater than minus pi by 2, that is going to be occurring just greater than pi by 2 over here. Right? The period of tan x and cot x is basically pi. And then again, secant and cosecant x, you have a period of 2 pi, because that is the period of sin x and cos x. Right? And then you have the examples. These examples are important, very important, because you get to see a lot of different behaviors that you haven't or wouldn't have encountered before, because you wouldn't have dealt with the real number nature of angles, but you would have dealt with the restricted angle set. Right, where 0 is less than theta is less than 360 degrees. With that, we go to exercise 3.2. Right. Find the values of the other 5 trigonometric functions in exercises 1 to 5. So the first part, that is cos x is minus pi by 2, minus 1 by 2. I'm sorry. Minus 1 by 2, and x belongs to the third quadrant. Right, I'm writing this colloquially. I can't write this. You can't write this as x belongs to 3 over here, while not specifying what this 3 is. Right, this is just a way for me to keep track of things. Right, write that x belongs to third quadrant if you want to, or if you really have to, write that pi is less than x. Pi is less than x is less than 3 by 2. That is the angle bound for the third quadrant. right? You can write this, no big issue. Since cos x is minus 1 by 2, that means that x is basically, right, since the value of the value of x for which cos x is 1 by 2 is going to be in the first quadrant, that is x is equal to this pi by 3, right? Because for cos 60 you have 1 by 2, right? Sin 30 is half, cos 60 is half, so x is pi by 3, right? That means that cos x being minus 1 by 2, especially in the third quadrant, means that this is basically, let this be x1, and I can cut this as x. So x is basically what? This 5 plus x, right? Yeah, this is basically 5 plus x. So we have x to be 5 plus pi by 3, which is 4 pi by 3. Right? You can plug this in and check. This 4 pi by 3 is basically cos of 240 degrees, right? That is going to be equal to cos of 120 degrees, and cos 120 is basically what? It's cos of 180 minus 60, that is minus cos 60, that is half, right? I just prove that whatever calculation I've done here is correct, right? So we have the fact that x is 4 by 3, right? And so you can get the values of the other 5 trigonometric ratios, right? Where you can write this. Yeah, you can write sin x is basically equal to, this is what? Sine of 4 pi by 3, right? This is sine of 4 pi by 3. This is minus sine of 2 pi minus 4 pi by 3, that is basically 2 pi by 3, right? Which is minus sine of, this is 120 degrees, right? And sine of 120 is sine of 60, that is minus root 3 by 2. Yeah. You can also get this from the fact that sin x squared plus cos x squared is 1. From that, you can get that sin x squared is basically 3 by 4. And so sin x has to be plus minus root 3 by 2. Since x lies in the third quadrant, sin has to be negative, and so you get sin x is minus root 3 by 2. Whatever you want to do, you can do it, right? And from this, I can get the value of cosecant x, that is going to be minus 2 by root 3. I can get the value of secant x, that is going to be minus 2, right? Because this is 1 by sin x, and this is 1 by cos x, right? You should know this. And so finally, you have tan x, that is equal to sin by cos, that is minus root 3 by 2 divided by minus 1 by 2. That is going to be minus root 3. This is going to be plus root 3, right? And cot x is going to be equal to 1 by root 3. You have cosecant and secant being, you have cosecant and secant being minus 2 and minus 2 by root 3. I have tan being root 3, you have cot x being minus 1 by root 3, and you have sin x being equal to minus root 3 by 2. That's it. Right? Question number 2. You have sin x being 3 by 5 and x lies in the second quadrant. Three by 5 is a special, it's a special angle. Because if you draw the triangle, right, taking this to be the angle x, this to be the 90-degree angle, right? Sine of x is going to be 3 by 5. That means that this side is going to be 4 by 5, 4, right? 3, 4, and 5 make a Pythagorean triplet. So if sin x is 3 by 5, then cos x is basically equal to 4 by 5, right? And just a bit of extra information for all you people who are very very brilliant. You would have seen sine inverses in your calculators, right? If you want to see it, plug in sine inverse of 0.6 or sine inverse of 3/5. You'll get a value approximately of 37 degrees, right? Usually it's taken to be a fact that sine of 37 degrees is 3/5, even though it's 37 point something degrees. But that's usually neglected because that's a very infinitesimal. It's not infinitesimal, but it's a very negligent value compared to the big angle that is 37 degrees. Right? So this x is usually said to be 37 degrees when sine of x is 3/5. Then cos x is 4/5 because you can get this from the triangle, or you can get it from the fact that sine square plus cos square is 1. And whatever works. Right? Depends on it. So if sin x is this and cos x is this, the other angles are going to be pretty easy to get. Tan x is going to be sine by cos, that is going to be 3/4. Right? You have cos, you have tan. And then you have secant, that is going to be 1 by cos, that is going to be 5/4. You have cosecant, that is going to be 1 by sine, that is going to be 5 divided by 3. Right? And finally, you have cot x, which is going to be 1 by tan x, that is going to be 4/3. Right. The only problem is I've neglected to mention where x lies. Right? Since x lies in the second quadrant, that means that sine is positive, cos is not, tan is not, secant x is not, cosecant is positive, and cot x is negative. Right? Therefore, the actual values sin x when x belongs to the second quadrant is that sin x is 3/5, cos x is minus 4/5, tan x is minus 3/4, secant x is minus 5/4, cosecant x is plus 5/3, and cot x is minus 4/3. That concludes the second question. Going to the third question. Right, cot x is 3/4, x lies in the third quadrant. Right, cot x is 3/4. Right, and x lies the third quadrant. Right. Remember, just note that when cot x is 3/4 over here, we have mentioned tan x is minus 3/4 over. That means if this was the first quadrant, then this angle 37 degrees and this angle of x is going to be a complementary pair, right? So this is basically 5 plus 53 degrees, right? That is going to be 233 degrees, if I'm not wrong. Right, this is usually taken to be 53 degrees. If cot x is 3/4 and x is in the first quadrant, x is 53. Point something, but that's again negligible. Right. Since you have that, that means that tan x is basically equal to 4/3. Right. And since x is in the third quadrant, that means sin and cos both are negative. Right. And since you have the angle over here, x, this to be 4, this to be 3, and this to be 5, that means sin x is going to be equal to minus 4/5. Cos x is going to be equal to minus 3/5. Secant x is going to be equal to minus 5/3, and cosecant x is going to be equal to minus 5/4. Right. Finally, you have tan x being 4/3. Fine. Right. Part number 4. Secant x is 13/5. And x lies in the fourth quadrant. Right? It's 13/5 and x belongs to 4. Right. Since secant x is 13/5, you can basically state the first angle, that is cos x, is 5/13. Right? That means you can build your Pythagorean triplet from here x, this is 5, this is 13. That means that this side is 12. Wait a minute, wait a minute, wait a minute, wait a minute. I haven't changed sides. I'm sorry for that. This is going to be 12, this is going to be 5 because cos x is adjacent by hypotenuse, right? And so in a triangle, you have this right angle. So since cos x is 5 by 13, you have 5, 13, and 12 to be 3 sides. So it's pretty easy to, form the other angles. Sin x is going to be minus of 12 by 13 because x is in the fourth quadrant, right? So sin is negative, but the value it takes is going to be the same as the value from the triangle, right? Sin x is minus 12 by 13. Since cos x, that means that tan x is going to be minus sin x by cos x, or this is going to be plus sin x by plus cos x. That is going to be minus 12 by 5, right? And then cot x is going to be minus 5 by 12. And then cosecant x is going to be equal to minus 13 divided by 12. Right. These are the 5 values. Cos x is 5 by 13. Sin x is minus 12 by 13. And then cosecant x is minus 13 by 12. Tan x is minus 12 by 5. And cot x is minus 5 by 5. That's question number 4. Going to question number 5. Tan x is minus 5 by 12. Tan x is minus 5 by 12. X lies in the second quadrant. X belongs to 2. Right? If x belongs to 2, that means the sine and cosecant are positive. All others are negative. And so tan x is negative. From this, you can get that cot x is basically 1 by tan x, that is minus 12 by 5. First, elementary, right? And from this, again, you build the triangle, or you use whatever method that you know of, algebraic methods if you want to. So state that sin x by cos x is minus 5 by 12. 5 times cos x is 12 times sin x, whatever. Then square them both. Try to add them. Whatever you're left with, take the root. And you can do something like that. But, waste of time. I can just directly build the triangle or build the triangle. Go ahead and finish quite early. I won't even waste your time. That's it. So I'll take this to be 5, this to be 12, and this is 13 because sin is opposite by adjacent. This is 13, right? Since cot x is minus 12 by 5, that means that cos x is going to be equal to adjacent by hypotenuse. That is going to be 12 by 13. Since it's in the second quadrant, that means I have to add a minus, right? Then secant x is going to be minus 1 by cos x. That is going to be minus 13 divided by 12. And finally, sin x is going to be 5 by 13. Since it's the second quadrant, sin x is positive, so I'll just keep the plus as it is. All right, and cosecant x is going to be equal to 13 divided by 5. So these are the 5 values, right? Cot x is minus 12 by 5. And then sin x is basically 5 by 13. Cos x is minus 12 by 13. Secant x is minus 13 by 12. And cosecant x is 4 by 5. Right? Another thing, you really want to do an algebraic method, then what you do from here is basically use the fact that tan square x plus 1 is secant square x. Use this. Right? Do not, separate this as sine and cos. Then make 12 sine is equal to minus 5 cos. And then square them both. Don't do that. Never do that. Because that is going to lead you into a lot of trouble. All right. With this, you will get secant. From there, you'll get cos. From cos, you can manipulate to get sine and cosecant. That's not an issue. All right. Having said that, I'll move to question number 6. Find the values of the trigonometric functions in exercises 6 to 10. Sine of 765 degrees, right? Sine of 765 degrees. Two things. First of all, you can do this in 2 ways, all right? You can basically keep the angle in degrees itself or convert them to radians and then do it. And both ways are going to yield you the same answer finally. And both ways are going to be the exact same thing in whatever you proceed with. But here you'll just have an extra conversion to degrees radians. That's it. Right. So if we're going to keep it in degrees, first know that 765 is greater than 360. Right. That means that you can separate 765 as 360 times n plus x. Right. You can write this in this form. Right. Just if you see it, this is going to be 720 plus 45 degrees. Right. And 720 is basically 360 into 2. So I can write this as sine of 2 times 360 degrees plus 45 degrees, right? Since sine of 360 plus theta is sine theta, that means that I can just basically ignore this off. This is equal to sine of 45 degrees. That is going to be 1 by root. That's your answer, right? You convert this into radians. What's going to happen is basically you are going to be left with 765 degrees into pi divided by 180, right? Which is what? You have to make a calculation. 45 fours are 180, and then 45 ones are over here. You will be left with 315. That is going to be 90, right? So this you are going to have sine of 19 pi by 4, right? You should know that sine pi by 4 is 1 by root 2, right? Sine 3 pi by 4 is 1 by root 2. Sine of 5 and 7 pi by 4 are going to be minus 1 by root 2, right? So out of 1, 3, 5, 7, these are plus, these are minus. And then going ahead, 9, 11, 13, 15, these two are plus, these two are minus, right? So 17 and 19, for 19, you get a plus over here, right? But for every, for every 4n plus 1 or 4n plus 3 pi by 4, you have this to be 1 by root or 1 by root. That's it, right? Therefore, you will be left with this sine of 19 pi by 4. That is going to be plus 1 by root 2, right? Or you can simplify this as sine of, this is 4 fours are 16. This is what sine of 4 pi plus 3 pi by 4, right? Since sine of 4 pi plus theta is going to be sine theta, you can just ignore this. This basic sine of 3 pi by 4. That is going to be 1 by root. Wait a minute. Have I made a mistake somewhere? Yeah, this is not 19, this is 17. Very sorry for that. This is not 19, but this is 17. So over here, I'll just change this to 17, right? And over here, instead of 3, there will be just pi by 4. So I left with sine of pi by 4, that is going to be 1 by root anyway. The answer won't change, right? Two ways to do it. You can do it in any way. Both ways work, right? This way is simpler. But if you want to just show off that you know radians and radian conversions, then you can do this. Your wish. Question number 7. Cosecant of minus 1410 degrees, right? Cosecant of minus 1410 degrees. Remember that, just ignore this minus for now. Separate 1410 as 360 into n plus x, right? So if you make this as 360 into 3, because 360 into 2 over here, you have seen that that's 720, right? So if I take n equals 3, this is going to be trial and error a lot. If I take this as 360, then I'll get this as 1410 is basically 360 times 3, that is going to be 1080 plus x, which means that I'll be left with 350 degrees, right? 350 degrees over here, it's going to be equal to x. Wait, now 350 is 330. 330, I'm sorry. This is 330 degrees. And that's going to be x. So therefore, you have this cosecant minus 1410 degrees. That is going to be equal to cosecant of minus 3 into 360 degrees minus this is 330 degrees, right? Or you can write this as cosecant of minus 4 into 360 degrees plus 30 degrees, right? Inside over here, I've just subtracted and added 360. The subtracted 360 goes over here, and this I'll add 360. Right. So since n times 360 makes no difference, that's a complete circle, right? I'm basically left with cosecant of 30 degrees. Since sin 30 is half, cosecant 30 is 2. That's your answer. Right. Question number 8. Tan of 19 pi by 3. Right, we've just done a similar sum, but that was a sine of 17 pi by 4. Right. Tan of 19 pi by 3. Right. This is basically, I can write this as tan of 3, 6 are 18, right? So that is 6 pi plus 5 pi 3. This is 2n pi, right? Which is n complete revolutions. Right? This is basically 3 complete revolutions. Right? And complete revolution makes no change. So I can basically ignore this. This is equal to tan of pi by 3. That is going to be root 3. Right? Because pi by 3 is substitute. Right. Question number 9. Sine of minus 11 pi by 3. Again, similar situation, but that I'll equate this with 7, right? Because over here, I've done a nifty trick to make this positive instead of negative. So here, over here, there's a sine of minus 7 pi by 3. I can write this as sine of 12 by 3 pi minus pi by 3. Right? A whole minus, which means that this becomes minus, this becomes plus. This is basically sine of minus 12 by 3 pi plus pi by 3, because minus 12 plus 1 is minus 11, which is basically equal to sine of minus 4 pi plus pi by 3. Right? And since this is basically 2 and pi, these are complete revolutions. They make no difference. This is basically equal to sine of pi by 3. That is going to be root 3 by 2. Right. And finally, the last question. Chord of minus 15 pi by 4. Minus 15 pi divided by 4. This is, you can represent this as, again, this is chord of minus 16 by 4 pi plus pi by 4. Right? Because this is minus 16 plus 1, that is minus 15. And so I can write it this way. This is basically chord of minus 4 pi plus pi by 4. Right? Since 4 pi is 2 complete revolutions, you can basically ignore it, because chord of 2 and pi plus theta is chord theta. Whatever of 2 and pi plus theta is whatever into theta. You can just remember that. If you have complete evolutions, you can basically ignore them, right? Which is chord of pi by 4, which is 1, right? With that, we complete exercise 3.2. All right. Fine. The next part deals with the trigonometric functions of sums and difference of angles, right? You know that the identities are sin minus x is minus sin x, cos of minus x is cos x, tan of minus x is minus tan x, etc., etc., and so on and so on. Okay, those are identities. But now you're going to deal with the formulas of sum, the formulas of difference, and sums of two cosines, sums of two sines, those formulas, right? Bit different, but they're also pretty easy to remember. And the derivations are also very easy, right? You draw a circle, you take a triangle, mostly an isosceles triangle because you deal with two radii, right? And you deal with x, y, and whatever minus y over there, right? With that, you get the formulas of all these different angles and the angle sums. And there is a list of, I think, 21 formulae over here. Yeah, there is a list of 21. Out of which there are some 4 subparts over here. There are some 4 subparts over here. And well, none here, right? Over here. There are 8 subparts over here. Whatever. Right? Read upon this formula because they are very important, and read on how many ever forms are given over here, right? Because for some formulae like cos 2x and sin 2x, you have expressions in terms of cos x, you have expressions in terms of sin x, you have expressions in terms of cos and sin both, and you have an expression in tan x, right? Similarly, for sin 2x, you have an expression in tan x, right? Which is pretty useful when you're dealing with half angles, because sometimes you have sin x and you really want to, express that in terms of tan x by 2, because you'll have something plus cos of something else, something like that. That means that tan is going to be useful because tan is going to be a common denominator, right? So, those forms are going to be pretty useful for you. Right, and tan 2x over here, you have sin 3x, you have cos 3x, tan 3x, right? And then you will have these 4 formulae, that is the sums of cosines, sums of sines, difference of cosines, difference of sines. You'll notice that cos x plus cos y is 2 cos of x plus y by 2, cos of x minus y by 2. And similarly for these, right? You basically get that from these formulae, the derivations are given below, right? You can check that, read them, and deal with all these examples, because you have to use these formulae to notice why exactly they're given, right? Because there is a reason to make life easier for you, to make questions easier for you. But these formulae are very, very, very important, right? Because you'll be tested in whatever way which we're playing, and you'll be using them in differential and integral calculus. With that, I jump to exercise 3.3. I just started with the formula. I haven't talked about the formula themselves, right? I just hope that you guys have read it properly. You guys will solve the examples, because there are a lot of good examples, and there is a high chance that your exams may be based on this example also. Not to give you hope. Right? Prove that, question number 1. Prove that sine squared pi by 6 plus